Okay, now we move on to different types of event in probability. There are 4 types of event in probability. So the first one is mutually exclusive event. The second one is complementary event. Okay, this complementary event I have discussed in previous video. The third one is exhaustive event, while the last one will be independent event. So we will focus more on mutually exclusive event as well as independent event. Okay, the first one is mutually exclusive event. Here, mutually exclusive events is the event that could not happen at the same time, which means that if you have event A and you have event B, so A and B cannot occur at the same time. Or in other part, we can say that the two events don't have any common point. I illustrate the information in this Venn diagram figure. Okay, if you look here, we have two events, event A and event B. So there is no intersection or there is no common between these two events. These two events state that A intersect with B is equals to 0. Okay, now the example that I can give for this mutually exclusive event is that if you have a dice, okay, one dice. Okay, when you roll a dice, you can only have one number. It's either you can have number 1, 2, 3, 4, 5, 6. This is kind of number that you can get from one dice. You cannot have two value occur from rolling one dice. Real life situation for mutually exclusive event that I can give is that you cannot attend two classes at the same time. You cannot attend statistic class and at the same time you attend another classes, let's say English class. Okay, that one is mutually exclusive event. Two events cannot occur at the same time. From the mutually exclusive event, we can have the addition rule of probability. So what is this addition rule of probability? Okay, let's say if A and B are mutually exclusive event, then the probability of A union B is equal to probability of A plus with probability of B. Okay, this additional rule can be applied on mutually exclusive event as well as non-mutually exclusive event. Look first on the mutually exclusive event. So this is your sample space of the pink rectangle. So this is your event A and this is your event B. So when we talk about mutually exclusive event here, you have to remember it's either A occurred or B occurred. It cannot be both A and B occurred. So there will be no intersection here. Therefore, the probability of A union B, that means that A or B in which either A occur or B occur or A and B occur, again, since this is mutually exclusive event, it should not have A and B. And therefore, the probability for this part will be probability of A plus with probability of B. Now, let's say if you have a non-mutually exclusive event. So, if non-mutually exclusive event, so this is the sample space. It will be event A here and there will be event B here. So, there will be an intersection. Okay, this is for non-mutually exclusive event. So, if you want to count, the probability of A union B for this non-mutually exclusive event, you have to be careful with the intersection information. Okay, because you have probability of A and then you have probability of B. Here you have probability of A and B. So you will count it twice for this information. So in addition rule for non-mutually exclusive event, it will be probability of A union B is equals to probability of A plus B probability of B minus probability of A intersect B. The purpose of minus the probability of A intersect B is to overcome the problem of counting probability of A and B twice. Okay, now let's take a look in this experiment. A single die is rolled. So what is the probability of rolling a number 2 or a number 5? So remember, if you use single dice, you only have one outcome. It's either number 2 or you can have number 5. So this is a mutually exclusive event. Two events cannot occur at the same times. So we look first the additional rule 1. The additional rule 1 here is denoted as the probability of mutually exclusive event additional rule. So here is the formula. Probability of A union B equals to probability of A plus probability of B. Now let me denote A as event of getting number 2. Okay, and B of event getting number 5 on the face dice. Okay, so what is the probability of getting A or B? So you know that probability of A, you will get 1 over 6. Okay, because you have 6 number on the die. And you have only 1 number for 2. And same goes for probability of B. It will be 1 over 5. So therefore, if you want to find probability of A union B, it will be 1 over 6 plus 1 over 6. So you will have the value of 2 over 6 or 1 over 3. Okay, we'll take a look another example, another experiment. In a statistic class of 30 students, 17 are boys and 13 are girls. A unit of tests, 4 boys and 5 girls score an A grade. If a student is chosen at random, what is the probability of choosing a girl or a student? So now, the question wants to choose a girl or an A student. So this information use the addition rules 2. The addition rules 2 is referring to non-mutually exclusive event where you have an intersection of event A and event B. So the formula will be probability of A union B is equals to probability of A plus with probability of B minus with probability of A and B. So in this experiment, the A event will be referring to the girls, while the B event will referring to student with A grades. So, what is probability of the girls? So we have 13 girls in a class. So 13 over 30. As for B, the 8th grade. So how many students with grade A? So this is grade A. You have 4 boys and 5 girls. So now probability of B will be 9 over 30. So from this 9 over 30, now let me illustrate the information in Venn diagram. So here is the girl and here is the grade A. So the grade A here, how many girls in this grade A? Will be 5 students here. Okay? So from these 5 students, 4 will be boy. And from this whole A set, these 5 students have grades A and the rest will be 8 students with other than grade A. Therefore, to get the probability of A union B, in this case, it will be probability of A union B equals to probability of A 13 over 30 plus with probability of B is 9 over 30, and you have an intersection, the common information in this figure. It will be 5 over 30. So therefore, this information will give you 17 over 30.